Hi students, I've got a supplemental structural video for you here. So let's take a look at CH2BR2, and again you'll have to go ahead and ignore the formatting weirdness that is caused by going from PowerPoint to PDF there. It doesn't seem to like the subscripts. But anyway, CH2BR2, let's talk about the full structural formula. So in the full structural formula, we're going to want to draw every atom in every bond. So what that'll look like for CH2BR2 is this. Now, if you're not quite sure how I came up with that structure pretty quickly, you might want to review the Lewis Structures videos that's on our Canvas shell. Also, if you're thinking, whoa, wait a minute, I would have put those bromines on one on each of those carbons, absolutely. But we're going to get to that in just a second. So this one right here would be a 1,1 dibromo ethene, or the old name for it is ethylene, but this one is ethene according to IUPAC. Now, how would we do that for our condensed structure? Well, we would go ahead and start with the double bond right there. So if you put carbon double bond carbon and then put H2 over here, that should make a lot of sense. So if we back up and look at those two bromines right there, and we see what we did with the hydrogens, it should be pretty obvious that you'd go ahead and put Br2 just like that. So that would be the condensed formula. And again, the condensed formula or the condensed structure is usually used in books or when you're writing something and you want to save some space or you just don't feel like drawing out all of the bonds. Now the line bond structure on this one. So with the line bond or the skeletal structure, you want to try to avoid drawing any bonds that you don't need to. Now, you need to draw in all of the carbon-carbon single, double, and triple bonds, but the ones you want to avoid drawing are carbon-hydrogen bonds. And that's really nice because then we don't have to count hydrogens on each of our carbons. And you also want to draw in the bonds for anything else, like a bromine. All right, so we're going to draw carbon-carbon double bond right there. And we're not going to draw the carbon atoms, but we're going to draw atoms if they're not carbon or hydrogen. So we've got to draw those bromines. So we've got one down there, and we've got one up there. And we want to assume that there's a carbon here and a carbon there, and also, like I said, you want to avoid drawing the hydrogens in, but we know that they're right there, so that's what it looks like when it's just sitting there in your regular old line bond structure like that. Okay, so that's what that looks like. All right, now let's go back to the case of one bromine on each of our carbons. So we can say, okay, bromine here and bromine here, which would mean that our hydrogen's here and our hydrogen is here. Now, maybe some of you said, well, wait a minute. I wanted to draw one of my bromines up and one of my bromines down. So what's the difference there? And can you do that? Yes, you absolutely can. We could have drawn it like that also, and that's a totally valid structure. And what's the difference between those two? Well, we've got the big groups on the same side of the double bond here. So this one is going to be cis 1,2 dibromoethene. And this one down here at the bottom that has your bromines across the double bond is going to be trans 1,2 dibromoethene. Now, how would we draw the condensed structure for those ones? Well, what we'd do is we'd say Br, CH, and then CH, Br. Now the BRs are on the outside right here because we definitely want to indicate that you're not double bonding a bromine to anything. So you don't want to stick them on the inside anywhere. But the weird thing is that a lot of times we'll go ahead and locate the hydrogen right there in the condensed structure, and we just expect that the person reading it understands that it's the carbon and carbon that are doing the double bond. And even though the hydrogen's right there, it's not doing the double bond because hydrogen's only ever like a what? They only ever like a single bond. So I know some of these quirks of drawing structures are just like, what? In chemistry, but that's just how it is. Sorry, my friends. All right, so for the condensed formula for the trans 1,2-dibromoethene, what you'll notice is it looks a whole lot like the cis version. So these two right here represent a fact in chemistry, which is often that the condensed structure doesn't show you which isomer you have if you do in fact have a couple of choices there, okay? And yeah, sometimes they can be the same for the condensed structure. Now, for these two right here, those are stereoisomers. So they have the same molecular formula, CH2Br2. They have the same connection of atoms. So you have a bromine that's bonded to a carbon, which is bonded to a hydrogen, which is bonded that, and also double bonded to a carbon, another carbon. And that second carbon is bonded to a bromine and it's bonded to a hydrogen. So they're both the same, but they're different spatially. Now, the one up here on the top, that's also an isomer of the two on the bottom, but it's just a regular old structural or constitutional isomer of those two because it has the same molecular formula, but it doesn't have the same connection of atoms because right here, you've got a carbon that's bonded to two bromines, whereas here and here, you don't have a carbon that's bonded to two bromines. You have a carbon that's bonded to a bromine and a hydrogen, okay? So this one up here has a different connection of atoms than the two below, okay? So they're all isomers of each other, but the top one, the 1,1-dibromo, that's a constitutional or structural isomer of the two below. And the two below are cis-trans isomers or stereoisomers of each other. All right, so going on to the line bond structure. So the line bond structure actually is going to show us cis and trans. So what we want to do is go ahead and draw the carbon-carbon double bond. And then we'll go ahead and put bromine up like that for our cis. And again, what is coming off of those carbons right there that we don't see? Those are hydrogens, okay? So I'm going to go back and erase those because you don't want those in the line bond structure. I just wanted to show you what was there. And for the trans 1,2-dibromoethene, you're going to see Br, the double bond, and Br. You could also flip that upside down, and what you would have is that structure right there, and those are both the same exact thing. Okay, so let's go on to C5H10, and I'm going to show you one isomer of C5H10 on this slide, and that is cyclopentane. Now for the cyclic structures, like with the other full structures or full structural formulas, you want to draw every atom and every bond, and you can see that right here. And for the condensed structure, what we're doing is we're just condensing things down a little bit. We're saving ourselves a little bit of time. So for this one, you do have to draw the ring. You don't want to do something like this, because that's saying that you have a straight chain or you don't have a ring. You need to connect them to show that you have a ring structure. So this is not going to be correct. You also don't want to do this, because how are they connected? Okay, you have to show it. And how we save a little bit of time, or how we condense the full structure down, is we draw all of these as CH2s, and you can see them over there. And again, H2C is the same as CH2, my friends. Right here where it's H2C, it's just being a little more precise in that it's showing you that those hydrogens do not point into the cyclic structure, they point towards the outside. Now with the line bond structure, you're not drawing any of your atoms and you're not drawing any of your carbon-hydrogen bonds. You are just assuming a whole lot of things. So each of these points, we assume that there's a carbon, and because each of our carbon is bonded to two other carbons, that's a quartet. And so we just have to know that carbons like to have an octet. So the other two single bonds that they're going to have are two hydrogens all the way around. And I'm going to go back and I'm going to erase all that, because in your line bond structure, you should not have those.